This is Ryan from the Vertical Axis Wind Turbine team from Glasgow Caledonian University. We just set up a presentation here to explain some of the fluid dynamic experiments that we have posted and how they relate to the project. First experiment with the two hanging balloons was to demonstrate something called Bernoulli's principle. This explains how the air behaves when we increase its speed in relation to the surrounding air. Bernoulli's principle tells us that when the velocity of air increases, the pressure will decrease, which also means that when the velocity of the air decreases, the pressure will increase. So, in the experiment, when we blow through the straw between the two balloons, we increase the speed of the air compared to the surrounding environment. This means that the pressure in the area will drop, shown by blue here in the middle. We also know objects like to move into lower areas of pressure, and this can be demonstrated by the balloons coming together, shown by the blue and yellow arrows. This is just a video of me doing the experiment, and as you can see, when I blow through the straw, the balloons come together as explained. So every time I blow, that's when the balloons will come together. So here you can see a topside view of one of the wind turbine blades where the colours explain the pressure differences made by the shape of the airfoil. The chart circled in red at the left just tells us low pressure is shown by the colour blue and high pressure is shown by the colour red. And the three arrows is to show what direction the air is travelling in. Shape of the airfoil and the angle it meets the flow of air creates a lower pressure above, since the air travels faster over the top than it does the bottom. And if we remember from Bernoulli's balloon experiment, an object, which in this case would be the airfoil, will move towards the area of low pressure, shown by the yellow arrow here. Here we have the straw and ball experiment, which was used to demonstrate the Coanda effect. The Coanda effect tells us that a moving fluid will stick to a curved surface of an object instead of being deflected away, which we might expect. What this means is that the flow of air from the straw will circle around the ball, which will trap it on all sides. This is actually quite interesting, since it creates a wall of air around it, which will make it levitate under our own breath. Here on the left, you can see me taking a deep breath to hold the ball in place, using nothing but the air from the straw. And here on the right, I've replaced the straw with a hairdryer so that it can hold the ball up for longer. I've also tilted the hairdryer so you can see that this works even at an angle. The last experiment was used to demonstrate Newton's third law of motion. There are three of Newton's laws, but the one that we're most interested in is the third law, which tells us for every action there's an equal and opposite reaction. So what this means for the experiment is that air has mass and is being released from the balloon in one direction. Then the balloon, which also has mass, will move in the opposite direction with an equal force. This is shown by the diagram, where the blue arrows is the air being forced out of the balloon, and the yellow arrow shows the direction of the balloon travelling in the opposite direction. And here you can see the experiment set up and how the balloon travels in one direction due to the air being forced out. It's quite a short one there, I'll play it again. Here the arrows show the airflow over the top of the airfoil, and just like the Coanda effect experiment with the straw and ball, the flow of air follows the shape of the curved surface and is directed downwards, as you can see. And finally, if we consider the mass of the air leaving the end of the airfoil, Then Newton's third law tells us that the airfoil with its own mass will move up and forwards in the opposite direction, shown by the yellow arrow. So by understanding these three simple experiments, we can use the air's behaviour to create a more efficient wind turbine by designing an airfoil that will turn the turbine faster. That brings us to the end of the presentation. Thank you for listening, and if you have any questions, just tweet us below. Thanks, goodbye.